Hi, Assalamualaikum and very good day everyone. Okay, so today we'll meet again on chapter 6 part 3. Okay, previously on the first and second part of chapter 6, I believe that you all already know about few terms such as spectroscopy, energy transfer, absorption, emissions, transmittance, Beer's law, and etc. So today, on part 3, we focus on the instrument that use on the spectroscopy theory. Okay, before we go further on the part 3, I would like you guys to recap the earlier part. So please assess yourself. So take your time, read carefully, and all the best. By the way, if you do want to do it at the end of the session, also can. So if you do want to do it at the end of the session, let's proceed. Okay. So basically, there are various instruments that use the spectroscopy theory. So the instruments can be looked at first part. So we already mentioned few equipments that fall under spectroscopy. So first and foremost, I would like to highlight on the UV visible spectroscopy. Okay, when we look into this figure, we may see that the UV visible is located between X-rays and infrared, where the wavelength between 200 nanometer up to 750 nanometer. Okay, for UV visible spectroscopy, the term itself consists of two terms, which are UV, ultraviolet, and vis, visible. So therefore, it consists of two regions. Okay, the first region, which is under UV, ultraviolet, the wavelength is in between 200 nanometer to 450 nanometer. Meanwhile, for the visible region, the wavelength is in between 450 nanometer to 750 nanometer. In the visible region, we can see only a small portion of the electromagnetic spectrum. Okay, before we go in detail, I would like you guys to have a look at this video.
Here's how a spectrophotometer works. A lamp provides the source of light. The beam of light strikes the diffraction grating, which works like a prism, and separates the light into its component wavelengths. The grating is rotated so that only a specific wavelength of light reaches the exit slit. Then the light interacts with the sample. From this point, the detector measures the transmittance and absorbance of the sample. Transmittance refers to the amount of light that passes completely through the sample and strikes the detector. Absorbance is a measurement of light that is absorbed by the sample. The detector senses the light being transmitted through the sample and converts this information into a digital display.
Okay, from the previous video, I believe that you get some information on the UV visible spectroscopy. Okay, so what is the purpose of using UV visible spectroscopy? Okay, by using the UV visible spectroscopy, we can identify the component of the sample, but in qualitative analysis. Why qualitative? It is because the sample in UV visible spectroscopy is in a mixture form. Okay. Okay, this following figure shows the schematic diagram of UV visible spectroscopy. So generally, the UV visible spectroscopy consists of 4 main items, which are the source, the wavelength selector, the sample cell, and detector. Okay, we go one by one. So the source is used to provide the light to the sample. Okay, so the source can be either deuterium lamp or xenon arc lamp, halogen lamp, or tungsten lamp. So basically, the choosing of the sources is based on the need. So means that what is the purpose of this machine, for example. So therefore, they will choose based on the need. Okay. Second is the wavelength selector. So in the wavelength selector, it consists of monochromators and also the filter. Okay, generally, by using the UV visible spectroscopy, we must have the idea what is the wavelength that we want to measure, or what is the component we want to measure. So means that we cannot just put the sample without knowing anything. Okay, you must have the idea what sort of component that you want to measure and what is the wavelength of that component. Next is the sample container. So sample container we also call as a cuvette. So the cuvette can be either from silica, quartz, glass, or plastic. So when we look into this sample container or the cuvette, then we can see that the sample that suit for the UV visible spectroscopy must be in liquid form. So the solid form cannot use. So for example, if you do have a solid form, then you have to dilute it. If the sample that you diluted is not cannot be dilute, for example, then the UV visible is not suit for that sample. Next is the detector. So detector used to detect all the light that has been passed through to the sample. Okay, so the detector can either phototube, photomultiplier tube, photodiode array, or CCD array. Then how to get the information? So then have to go to the signal processor, so read out device. Okay, so basically UV visible spectroscopy can be divided into 2 types. So what is the difference between these 2 types? Okay, the first type is single beam and the second type is a double beam. For single beam, it employs a single source to supply radiation to the sample and then the background in turn. Okay, the advantage, single set of component is required. Okay, while the disadvantage is separate correction must be done for background spectrum. Okay, so let's have a look at this diagram. So first of all, the source go to the monochromator, and then the sample cell, and the detector. So basically the difference between single beam and the double beam is here. Okay, so from the monochromator to the sample cell or the reference cell. So when we look into the single beam, there is only a one line in which from the monochromator to the cell, reference cell, and then to the detector. So if we want to measure the sample, then we have to replace the place of this reference cell to the sample cell. So that's why longer time is needed to measure, to complete the measurement. Okay, while for the double beam, a single source supplies equal intensity beams through the sample and reference. So let's have a look at the diagram. So from the source to the monochromator to the reference to the cell container to the detector. Okay, so in double beam spectroscopy, they have the beam splitter, or we call as a chopper. Okay, so what is the purpose of this beam splitter or chopper? So by using this, they can measure two things at one time. So the sample and the reference. Okay, so therefore by using the double beam spectroscopy, shorter time measurement can be collected. Okay, so these are the applications of the UV visible spectroscopy. So by using this UV visible spectroscopy, we can analyze the vitamins, fatty acid, analgesic tablets, proteins, trace metals, or the food coloring. So the basic principle of this UV visible spectroscopy, whatever components that can produce color in the region of UV visible, then we can use the UV visible spectroscopy. Okay, there are other instruments which fall under spectroscopy, such as infrared spectroscopy, atomic emission spectroscopy, atomic absorption spectroscopy, and also inductively coupled plasma spectrometry. Okay, so all these instruments can be collected from your task for the project presentation. Okay, that's all. Thank you. Bye.